This is Professor Pelton. This is Algebra 2, Chapter 7, Section 2, Graphing Rational Functions. This is part 3 of the video. Now, before we get to the graphing, the last thing we need to do is analyze horizontal and slant asymptotes. So essentially, you have three scenarios. Uh, Rational functions are polynomials over polynomials, and the leading term is what's most important. So I'm going to use n for the leading exponent of the top term and m for the leading term of the bottom polynomial, thus the highest exponent in either. So the other terms don't really matter because the largest term is going to grow the fastest and the other ones just kind of tail off mathematically. So if the n is less, you're going to have a y equals 0 horizontal asymptote. If they are equal, you'll have an a over b y equals horizontal asymptote, where a and b are the leading coefficients. And lastly, if the bottom is less than the top, then it's going to go to infinity. Thus, you will have a slant asymptote, which means you'll have to do a polynomial long division. Okay. Okay, so let's try the three scenarios here and find out what happens. So you can either have a horizontal asymptote or a slant. So there are two scenarios where you have a horizontal asymptote. In one scenario, we have a slant. You have one or the other. Versus the holes in vertical asymptotes, you either had you could have one, the other, both, or neither in those. In this case, it's one or the other or neither. Okay, so scenario one. For each of these scenarios, I'm going to use the same method, which is plugging in infinity. So again, the only thing that matters is the leading term. Because essentially what you're going to do is, these are y equals equations, you're going to plug in infinity. So adding 16, or I'm sorry, subtracting 16 and subtracting 9 from infinity doesn't really make any difference whatsoever, okay? So essentially what you have is infinity squared over infinity squared, which cancel each other, leaving you with 2/3. Okay, so y equals 2/3 is the horizontal asymptote. Thus, there is no slant here. And you can see that they are of equal power, which is scenario 2. Okay, so let's look at the graph to verify that's actually true. So we'll make a new graph. So the numerator was 2x squared minus 16 divided by 3x squared, whoops, plus 9. Okay, and you notice that there is no vertical asymptote here, but at 2/3, if I can get my pen open right then and click it, at 2/3 there is a invisible line that it's approaching as it goes to infinity, which is your y equals 2/3. Okay. Okay, let's go to the second problem. All right, in this scenario, the bottom is bigger than the top, which is interesting. So if I plug in infinity, oops, that's not what I want to do there. I'm changing our function to a y equals infinity over 4 times infinity squared. Because again, only the leading terms matter because the other ones don't matter. Adding 3 and minusing 5 is not going to do anything to infinity. Okay, so that's really a 1 right there if you think about it. So I have infinity to the first power over infinity squared. So that's going to give me 1 over 4 times infinity. Well, 4 times infinity is just going to be infinity. So if I take 1 and divide it up into infinite parts, you've basically destroyed it into so many parts there's nothing left. So essentially it's the nuclear option. You divided 1 to infinite parts, so you have 0 left over. So think of it this way. If you have 1 pizza, you divide it up amongst infinite people, you're going to starve to death. You got 0 pizza. Okay? So in this case, I have a horizontal asymptote okay, of y equals 0. All right, so that is scenario 1, where the um, bottom is bigger than the top as far as the power goes. So let's look in the calculator and see what that looks like. So we have x plus 3 in the numerator, and then I believe we had a 4x squared minus 5 in the denominator. Okay, and you notice that we do have parts in top and bottom, but the end behavior of the graph is this horizontal line of y equals 0 that's approaching as it goes to infinity and negative infinity. Okay, because that's what it's approaching for the x value. Hence why we plugged in infinity. Okay, third problem. All right, so in this case, we have the top bigger than the bottom. So if I tried to plug in infinity, it'd be infinity squared over infinity, which is really to the first power, because it's x to the first power, which is really infinity over 1 when you cancel. So y equals infinity, which basically means there is no horizontal asymptote, which there must be a slant, so you must do long division. So x minus 3 divided into x squared plus 3, which of course is wrong. I have to erase the 3 and put a 0x plus 3, because when doing long division, there cannot be any missing terms. Whoops, didn't connect that correctly. Oh well. Okay, so the first term is x. X times x is x squared. X times negative 3 is negative 3x. And we'll subtract. So that'll give us 3x plus 3. So my next term is plus 3. So that gives me 3x minus 9 when I multiply. So I'll subtract. So that gives me a final constant remainder of 12. So plus 12 over x minus 3. So the remainder of 12 over x minus 3 doesn't matter, because if you plug in infinity into there, it's 12 divided by infinity minus 3. Thus 12 divided by infinity. So if you take 12 and divide it by infinity, you get nothing, because you took 12 and divided it up infinite times. So therefore we get a slant asymptote of y equals x plus 3. So it's essentially, it's a slant, which is a line. Okay, so we'll look at the graph to verify that's actually true. So we get an x squared here, and that was plus 3, right? And then x minus 3 on the bottom. Okay, and we can probably zoom out a little bit. That's actually a little bit off. Zoom. We'll just do fit for now. Ooh, that does not look good. Oh, it's up to 600. That's why. We'll do. Let's see here. Zoom bot. No, that's not what I want. Menu. Zoom settings. Negative 20 to 20, I guess. That'll work. Ah, there we go. So you can see it's kind of up there. I should probably go a little bit more. Menu, window zoom setting. I don't know. We'll say 30. 30. Okay, either way. All right, so if you look, we have a line here. We said it was what, x plus 3? So essentially you have a line that goes like this, which is y equals x plus 3. And again, it's a dotted line because it's an asymptote. It's invisible. You can't actually see it. So the y-intercept would be 3, and the slope would be 1 over 1. Okay, pause the video and try the student problems for yourself. Okay, Next problem, the non-leading terms don't matter because they grow slower than the leading term. So I have y equals 3 times infinity squared over 4 times infinity squared, which they cancel, just like x squared over x squared would cancel, or any other variable rather. It's just infinity is specific. So that's 3/4. So we have a horizontal asymptote of y equals 3/4. So that's a scenario where the numerator and denominator have equivalent powers, so therefore you get a horizontal asymptote. And the next one, y equals 2 times infinity over 6 times infinity squared, because the non-leading terms don't matter. So I really get 2 over 6 and then an infinity on the bottom because we have 1 over 2. So I really get 2 over infinity, because 6 times infinity is still infinity, which is 0, because if you take 2 and divide it up infinite times, that's the nuclear option. There's nothing left. So again, we have a horizontal asymptote of y equals 0. Okay, last one, where we have the top bigger than the bottom as far as the leading exponent. I get y equals 2 times infinity squared over infinity, which is essentially 2 and times infinity once we cancel the powers, which is infinity. So that means there's no horizontal, right? Because you're going up to infinity, obviously, which is what a slant does. So we have to do the long division. So looking back at the original problem here, what do we have? X plus 1 divided by 2x squared plus 0x minus 5. So let's see, the first term would be 2x. So that gives me 2x squared plus 2x when I multiply, right? We'll subtract. So that gives me minus 2x minus 5. So my next multiple would be negative 2. So that gives me negative 2x minus 2. And that would give me a negative 3 for our final constant remainder. So it would be plus negative 3 over the x plus 1 I was dividing by. But the remainder doesn't matter because you're dividing out by an x, so it goes. So negative 3 divided by infinity just goes away. So I'm left with a slant asymptote of y equals 2x minus 2. Okay, and that is the end of part 3.